Hello and welcome to this fourth lesson for the Chapter 5 Geometric Applications of Differentiation. This shouldn't be that long of a lesson. We're just going to have a look at sketching curves involving derivative functions and a little bit of some different types of exam questions that can evolve around this. Okay, this one here is a really nice question. The diagram shows the graph of a function f of x. So this is showing us the f of x function. The graph has a horizontal point of inflection at A, a point of inflection at B, and a maximum turning point at C. Okay, so A is a horizontal point of inflection, B is a normal point of inflection, and C is a maximum turning point. Okay, let's just have a look at this. When we're looking at this function, right, what direction are both of these arrows pointing? They're both pointing down. So they're pointing in the same direction, which tells us that this has an even highest power. And when we derive, we're always going to lose one power. So we're going to go from an even to an odd power. And since this is pointing downwards, it's pointing downwards currently, that means that it's got a negative even leading term, and this will have a negative odd leading term. And odd will go in opposite direction arrows, and it's going to go something like that. So it will look approximately in that general vicinity of sketches. Right. Let's sketch what information we know. So I'm going to try to line up my axis so we can directly copy down. So we know that there's a horizontal point of inflection at A. A horizontal point of inflection has a gradient of 0. So it will actually, if we're drawing this as the y dash axis and this is the x axis, right? Y dash axis and this is the x axis, at the point A, or minus 2, it is going to it's going to touch that, right? It has to, because the gradient at that point is 0. Also at C, at the point 3, it will also touch 0, right? And we'll just work with this for now, and we'll figure out what's going to happen at B in a little bit. Okay, from here, we're going to figure out what's happening with our gradients. Okay, what's the gradient at this point? Not the value of it, but is it positive or negative? It's going to be a positive gradient. So that means from to the left of here, it's got to be above the axis, right? As it passes through there, what's happening? It's still positive. So to the right of here, it's got to be above the axis, right? Then what happens all the way through to B, it goes positive, positive, positive. And then when it gets to C, it goes negative. So after this point here, it must be negative. Okay, so I'm looking at this, and one thing that appears to me immediately is that on 2, it must come down to 0, but on either side, it must be above the axis. And what that tells me is that it must do something like that. It has to. There's no other way it can come down there, but still sit above the axis on both sides. It must come down only to that point and only touch it once. So this is a good thing to remember. A horizontal point of inflection will be something that looks like that. It comes down as a single root and only touches it once. All right? Now, what's going to happen in between? If we have a look here, I'm going to actually delete this just because it wasn't a good curve, right? What's going to happen in between? It's going to go up, and then it must cut down. It should actually cut through 3. I should show that. It should cut through 3 and then keep going. Okay, why is it going to do this? Well, we know that it has to be positive in between all of these points. It must be above the axis in between 2 and 3. So it has to just stay up here, but it must have a turning point halfway in between. Now, there is actually a particular point where this turning point is going to be, and that is at B. Okay, or I'll actually label it 1, right? It's at the coordinate along the x-coordinate of where B was. And I'm actually going to go back to the previous chapter just to have a look at what we're saying here. I know I said it was a bit confusing, but the second derivative shows the rate of change of the gradient, right? So it makes sense if there's a rate of change of the gradient is the second derivative, and we know at a point of inflection, it's going to be equal to 0, right? It makes sense that if it's going to be equal to 0, it's where it crosses. When we go one level up from that, it's going to appear to be a turning point. And this is something that's really difficult to wrap your head around, is that something goes from a point of inflection, that's the first thing that it hits, then it goes to a turning point when we derive once, and then it goes to a root when we derive once again, right? That's the order that things actually go in. If something's already just a turning point, it's going to go to a root, right? If something's a root, then it's not going to be involved anymore, right? There's no significance to -4 or 5. So just as an order of how things go, something's going to go from a point of inflection, then it goes from a point of inflection to becoming a turning point when we derive once, and from a turning point, it's going to become a root on the next function. And why is this important for the point A as well? Well, if we have a look, A was both a point of inflection and a turning point. So if we imagine it was here and here, then it gets bumped down on both levels. It is now a turning point and a root, which makes sense. Here we have a turning point as well as a root. So this is something that it takes a while to wrap your head around. The thing that I can just advise is try to practice a lot of exam questions involving this, because this isn't something that you can easily figure out in an exam. You have to be able to get this pretty quickly. The fact that it goes from point of inflection to turning point to a root, right? That's the order of how things go, and it will be impacted as well if it is a horizontal point of inflection. Okay, so this is approximately the sketch of the derivative. It's not that great. It doesn't have to be good as long as it shows the important critical points. Okay, here we have the diagram shows the graph of f-x, the derivative of a function. So they are now showing the derivative of a function. Okay, for what values of x does the graph of the function f of x have a point of inflection? Okay, let's go back up to the order of things. So I'm going to rewrite it down here. So it goes point of inflection, then it goes to a turning point, and then it goes to a root as we derive. So if they want something to be a point of inflection and they're showing us the derivative, we are looking for something that is a turning point, right? Just a turning point. We're just looking for a turning point. So A is not a turning point. D is a turning point, but so it's a stationary point, but it's not a turning point, right? It is a stationary point, and that is good, but it will also be a horizontal point of inflection, and we don't want that. The one that we're actually looking for is B, right? B is the turning point, so when that goes back up, right, it's actually going to become a point of inflection, right? So the answer is going to be B for this one, right? So always remember, point of inflection to a start point or a turning point, and then to a root. And this one here, I think this is the last question that we've actually got for these the curve sketching. The function f of x is defined for between the values of a and b, so between and equal to. On this interval, f dash x is greater than 0 and f double dash x is less than 0. Okay, let's have a think. F dash x is greater than 0. What does that mean? F dash x is greater than 0. That's a positive gradient. That means it's increasing, right? It's going in roughly that direction. And what does the second part mean? Second derivative is less than 0. Less than 0, remember, that means it's a negative number. That means frowny face. That means concave down. Negative is sad, concave down. So we're looking for something that's going in this direction, but the general shape will curve it down into this one. Let's have a look at what we've got. A is going in the right direction, and if we continue this along, it will point downwards. Okay, so our answer is most likely going to be A. Let's check the others. This is going in the right direction, but it's actually concave up, right? So it's going in the right direction, it's concave up. This is going in the wrong direction, but it has the right concavity, right? It's going in the right direction. Wrong direction. Wrong direction, it's going down, but it does have the right concavity. It is pointed down. This one is wrong on both counts. It's going in the wrong direction, and it also has the wrong concavity. This one's a smiley face, and it's going as a negative gradient. We wanted positive gradient and negative concavity. So our answer is A. Okay, thank you for joining me for this. We've just had a look at some curve sketching. If you didn't quite understand this one here, that's okay. Maybe come back to this topic or the curve sketching part at the end when you may have seen a little bit more to do with how the curve sketching actually works. It is a difficult concept to wrap your head around. You just need to get more and more exposure. That's all you can really need to get, right? So that's the only thing that's going to help with this. You can try to practice some other questions and that'll get you more exposure, which will make this easier to do. So that's all we've had a look at today. We've just looked at curves involving the derivative functions and sketching them.